Hi everyone, how are you today? Buenas tardes a todos. Buenas tardes. I'm super happy to be here. I'm very excited. You can see from my, well, you can hear from my voice. This is my first time at DevOps Barcelona, so yoo-hoo! Give it a round of applause. Perfect, thank you so much. So I hope you enjoyed your lunch, so I really don't want to make you doze off right now. It's just, one of those talks on GenAI. And yeah, let's start. So my name is Todea. I'm a senior SRE at EQS Group. And let's see. OK. So my main focus is on observability. I really love observability. But I also am into AI, machine learning. I'm an open source enthusiast. I support women in tech. So if you are presenting later on and you're a girl, just give it a round of applause. And I live in sunny Valencia, which is floody at the moment. So I barely made it today. So yeah, let's give a round of applause for Valencia and Malaga. Super excited. OK, so let's start. So today I'm going to be speaking about GenAI, right? It's a big topic. It's very trendy. And I thought about it because sometimes it's just a hit or miss, right? So you either like it or you just hate it. Basically, what I wanted to show you today is something that comes from a year of researching, something that I really wanted to show, not necessarily that I have tons of experience in. But just fortune made it that I also worked on some specific SRE projects on AI. So that's even more helpful for you because I'm also going to share some lessons learned. So I'm going to be focusing on some concepts. We need to rehash some of the theoretical concepts around GenAI. Observability, that's my main area of focus. The use case of AI assistants. And yeah, let's see how we can embed that into the SRE life, DevOps life, and what you can take from it. Yeah? Are you ready? OK, cool. So I wanted to put this slide on because this presentation is not a vendor pitch. From my side, I'm not here to sell you anything, so you can relax. I'm just simply sharing my ideas of what I experienced so far. So this is me coming to you with my presentation. Right, so where are we at the moment? I think we are all pretty much confused about all the terminology that's been happening in the last years or so, mainly this year. I mean, I was super confused to hear about lots of the new emerging concepts, the new trends. And we know that MLOps basically is just like DevOps culture applied to ML assets, right? So this is what it is, actually. It's DevOps culture, like the one that we know and came familiar to be familiar with, like CI/CD tooling, automation, versioning, and so forth. And this culture right now is being applied to data, data models, so basically data science. So by silosing ML assets from the versioning from the normal CI/CD tooling, MLOps is just basically trying to wrap it up under a new package and deliver to people something that, OK, MLOps is something good. Machine learning operations are actually there to make our lives more easy, more reliable. So I think this is where it's going, right? I did a bit more research because this doesn't stop at just MLOps. So right now, there's a new trend that we've been seeing, like LLM ops, just basically operations applied to LLM. And this can be very diversified because there are so many LLMs out there that are specialized for specific fields. If you want to take into consideration that LLM observability is actually the operation of taking into account and analyzing how a LLM operates, this is quite specialized. So from LLM observability, actually, you can get logs, traces, and so on. That will tell you a lot about how the LLM is doing, how the LLM is operating, and that's pretty good, right? How about AI Ops? Have you heard about it? Yeah, so it's basically ML, machine learning workflows being applied to IT operations. So how can machine learning actually make it more efficient, make IT operations more efficient with the help of AI? So by analyzing the data from IT operations, machine learning can actually help make it more reliable, faster, better, etc. IT operations. Well, this is kind of like trending down at the moment. And there's a new girl in town called agent SREs. So agent SREs basically are those, let's say, software assets, software agents that will help to understand context, communicate effectively, but applied to site reliability engineering tasks, right? So that's why they're called agent SREs. So basically, right now, everything is shifting, everything is being rebranded, but don't worry, I think we're gonna catch up with it, right? So, if you feel like in this meme right now, you're pretty much like myself, you're gonna be feeling a lot confused that you're a DevOps engineer or just an SRE, so don't worry, you're gonna be soon be called an MLOps engineer, right? Okay, so let's start with some theoretical concepts. So we cannot actually speak about generative AI without talking a bit about transformers and about attention mechanisms. So a transformer in machine learning is a neural network. So a transformer is a neural network, right? That learns context and meaning by tracking relationships in sequential data, just like the words in a sentence. So with the help of attention mechanisms, transformer actually ranks the weight of each vector and will pull that information accordingly when it gives the output. So that's quite interesting. Don't worry, everything will be explained later. All these concepts help us understand a bit more the transformer architecture and the generative AI architecture. So vector embeddings are those representations that are suitable for machine learning tasks, like clustering, recommendation, and classification. We need a vector database to store and index all those vector embeddings. So this is why it's very important to understand what's a vector database and what does it do. And like just with any database, in order to get some results, we need a search, right? So we'll need to perform a so-called ANN search that's very specific to machine learning. And in this context is the approximate nearest neighbor. So with the help of this search, actually, we are looking at all the vector embeddings, at all the vectors in the latent space, and we are pulling that information from the vector database. Cool. So let's take a look at this graph. This is actually a transformer architecture. That's a classical architecture that was coined in 2010, 2017. So the original concept or the original intent for the transformer was to help with the translation. So from different languages into English and vice versa. So with the help of self-attention mechanism or multi-headed attention, there are a couple of them. So with the help of attention mechanisms, the transformer actually weights the importance of each token. And then it will rank that specific token and will provide us the generated response. Okay, how does it work in practice? So if we go to, for example, this page, huggingface.co, that's a page that anybody can access, so it's free. It's called Expert Project, Expert, and here we can actually do a small exercise. So let's see how it works. So we just select the simple model, the bird-based model, that we can play with the layers there at the end, and we just put our sentence. So in this case, I'm using something super simple, like she reads a good novel, right? We press update, and let's see how it acts. So she reads a good novel. It's a fairly simple sentence. We can see the correlation of each token of each word with the other words in that specific phrase. And we can understand here that novel means book, right? So the weight, the rank of that specific meaning, it's correctly identified as being book. Now, if we are switching to another sentence, transformer is a novel idea, we can see that here, when we go to the same word novel, it's correctly identified as being new. So it has the correct meaning of new, so it's not a book. Basically, the transformer will look at all the words in that sentence, and with the attention mechanism, will try to grasp the context and the meaning. Okay, so that's, let's say, pretty much the theory and the practice. How does generative AI function in relation to a transformer architecture? Well, generative AI is pretty much the same thing, only it generates new content. So we can input like images, documents, audio files, so all the raw data that we want. Everything will be transformed into an embedding. So those vector representations then will go to the vector database. And via the search, like we saw earlier, we'll get the response, the results. Those results are going to be packaged, transformed back into embeddings, and the new generated response will be given to us. Why is it called generative AI? Because it gives us a new context. So content is not something old. So it's not something like you put it just like this, and it gives you exactly the same information. So for example, if you have in the raw data some images, like, I don't know, a bunch of images, you train the model with some images of animals, it can correctly identify from some disparate images. It can put two and two together and actually correlate some, let's say, the faces of some animals with the ears, and can correctly identify, okay, this is a cat, this is a dog, and will provide you that specific information in a new content. Okay, how does this workflow actually works? If we're going to try to make it more in detail. So if we take a look here, I'm not sure if this works. So everything starts with the data processing. Yeah, it works. So we have the raw data, then we go to data processing, which we have to be careful because all the data we're going to input needs to be cleaned. So we need to get rid of, I don't know, duplicates, or we need to get rid of blurs if we have images. We need to get rid of, I don't know, say, duplication or something that is not useful, just in general is not useful. So after we complete this step, we go to test chunking, which is very useful because it actually separates into smaller pieces the information. We've seen earlier in the phrase where it was transformer is a novel idea, transformer was actually separated, divided into different tokens. So it wasn't the whole word, it was like divided into 3 or 4 chunks. Right, and then we go to embedding generation, and this is where the magic happens in the latent space, and then it will go via the vector storage into the vector database. A vector database is super important because there you're going to just store the information, you're going to index it, and you're going to retrieve the results. So also the ranking will be done in the same space, in the storage database, sorry, in the vector database. And all the paths that are being created with the help of indexing will be very useful, because once all the vector embeddings are being indexed, then it's going to be very fast for those results to be retrieved. So think about a vector database as a normal database on steroids, right? Right, and right now, if we are the user here, user up, and we are performing a query, let's say we're just asking something, then it will go as a query vector. So think everything that we normally do is just simply called vector. It will go to a similarity search back to vector database. So we are performing that ANN search I was talking about earlier. And from the vector database, everything will be computed. So, OK, I'm going to retrieve the results. Cool. Then we'll give back the relevant documents, and we'll go to the phase of post-processing. And then the user or the application, whoever is getting the final results. So this is more or less like if you want to look in more detail how this works. So once we play around with vector databases or with the entire workflow of generative AI, we normally kind of choose between two popular methods, which I'm pretty sure you heard about before. It's retrieval augmented generation, that is also being quite popular at the moment, and fine-tuning. So both are pretty handy. RAG, retrieval augmented generation, is something specific because it connects to an external data source. So it connects to a vector database, an external data source, where we have already some information. And then it's going to grab that information from external sources and will generate the responses. Fine-tuning, on the other hand, is something that happens internally in the model. So it's basically that model that is being retrained over and over again to give very, very specific information, very, very specific task. So it's not something that happens externally, it happens directly on the model. So there is no additional retrieval component here. But you can also do something cool, and you can combine both methods. You can combine retrieval augmented generation, and you can combine fine-tuning. So you can do something like this, as I explained. You can pre-train the language model on broad data, so that's the first step. Then you're going to fine-tune the model with a data set specific to your application. And here you could go through the process of fine-tuning as many times as you want. And then you're going to implement a retrieval component that fetches relevant data from an external source. So this is the RAG part. And the fine-tuned model basically will use both these methods and will generate responses. So even better, right? So if we're going a bit under the hood and analyze how RAG process works, is a bit more, let's say, schematic like this. So the RAG starts obviously from the beginning with the user query. And then everything happens here in the query embedding that we saw earlier. It goes to semantic search. And what happens here? So this is the RAG process. This is actually where RAG, shines. It goes and searches in the vector database for that information. Prior to that, obviously, we inputted our data that was chunked and embedded into the vector database. And via the semantic search, we're going to retrieve the context, right? So generative AI is doing the thinking, hey, what is this? Where have I seen this before? It's trying to do the matching, re-ranking, and everything. So it's finding the context. And then it will, do with the help of prompt construction, it will generate the LLM. So in the end, we're going to get that augmented response. So the output, that is basically some new type of information. Cool. What about in real life? Have we seen this before, or are we familiar with any of the use cases? Well, I'm not sure. Probably you've seen like a lot of chatbots and serverless databases and whatnot. So obviously, there's a lot of there's a lot of offer there on the market. You can go serverless as well. I just put it out there because something usually people don't know that besides normal vector databases, there is also a flavor of serverless databases. So that's pretty cool. And besides the normal vendors, like the big ones, I added some open source vector database that is called LansDB. And there are there are many out there, especially if you look in the open source space. There are quite a lot emerging at the moment. Before actually starting and playing with everything, or even testing, or even trying to have fun in production if you don't want to go to testing, the first question would be like, okay, but is my infrastructure ready? Is it going to support everything that I want it to do? It's very, very important that your infrastructure bears that weight. One is super costly to run machine learning operations. If some of you are data scientists or even worked on projects related to machine learning, is super expensive to go there and buy resources, find the correct resources, then think about planning and scaling all those resources. So you need to think about, okay, how am I going to scale this? You need to think and take into account the latency. all the workflows that will run, all the concurrent inferences that will happen. So it's a significant load, it's a significant workload that your infrastructure will need to take. And that's something that you need to take into account as engineers, as managers, and so forth. Right. Well, this is my favorite part because it involves observability. Once you decide to, OK, I'm going to jump in, let's play with this, please think about observability. That is just like a normal workflow, just like in IT, just like in DevOps workflows, SRE workflows. You need to take into account adding some alerts or adding some monitoring, anything related to observability. And this is super important. You can also test it with observability being your raw data. Okay, so you have like lots of information, logs, metrics, traces, service level objectives, application performance monitoring data, whatever, synthetic monitoring, and so forth. You can add all this and put it in your database, in your external source, and then you can use it in the workflow of generative AI. And the part here that I'm trying to explain why I went a bit overboard with the theoretical part is that AI assistants, even probably for some people they look silly, they use both architectures. They use the transformers architecture and also the generative AI. So they will benefit from those attention mechanisms and also from the generative part. And once we are actually interacting with AI assistants, we are interacting with transformers and generative AI. So that's pretty cool. So let's see how we're going to be using observability data with generative AI. And here comes into play something that you probably know about, OpenTelemetry. What is OpenTelemetry? It's one of the most famous observability open source projects at the moment. How many of you have used in testing, production, OpenTelemetry? OK, this part here is pretty cool. OK, so don't worry. It's like I played with OpenTelemetry recently doing a POC, and it's quite, sometimes it's quite frustrating, but when you actually do have some information from it, can be really cool. So OpenTelemetry is open source project that's basically focused on distributed tracing and collects logs, traces, metrics, and it works basically with cloud-native technologies. Why is it cool? Because software engineers, developers usually use it with a lot of SDKs, right? So if you have applications, you can integrate it with OpenTelemetry depending on the SDK you are using. So everybody is using it at the moment. It's not super stable, so I'm not going to be advocating for it because they have their own developer advocates for it. I'm just going to say that it's there, it's available, and it's also integrated with generative AI. And it's doing a lot to make it blend with generative AI. So what OpenTelemetry brings to generative AI? There's actually a pretty cool talk given by this person here, Philip Carter from Honeycomb. They are one of the top vendors, developer advocates of OpenTelemetry. So he explains that OpenTelemetry helps generative AI in some of these aspects. You can use traces, like grab contextual inputs with the help of spans. You can gather metrics, basically about latency, costs, error rate, and so forth. You can grab, so those logs, you can grab it from the full LLM response, from the full prompt that you are using in the LLM, and you can analyze also the patterns, like the input and output patterns. Why is this useful? So if you remember back at that slide when I was talking about LLM observability, basically you can use all this workflow to grab the observability data and just get information on how your LLM is performing. So your LLM is going to be performing as it is, and you shouldn't be frustrated if it gives you some information in production. You can use all that data from production and ship it back to the testing. Ship it back to the testing phase and use it to retrain your LLM, your model. Right, so I did it. I played around with GenAI, and I found this meme online, and I thought it was pretty cool. So that's like the junior data scientist trying to do some funky stuff with ML models, and this guy comes and like, clean your data, It's like, yeah, so I learned the same thing, like this junior data scientist, is that it's super important to prepare your data. It's super important to clean it, make sure that you don't have like tons of unnecessary data there. Why? Because it's going to corrupt pretty much your results. So it can go in two ways. You can be super happy, and it could go in two ways once you're testing it. So you're there, and you're trying to use more or less data. So let's say you're going to say, yeah, OK, I'm going to put all my GitHub repos, all the knowledge bases. I'm using all those, data that I normally use when I'm being on call, etc. So I'm going to use it as an external database. What can go wrong? So you're going to see like lots of results that are not going to be that accurate, so be less quality results. Your response is going to be clunky in the sense that your AI assistant is going to respond a bit with a lot of delay. Why this happens? Not only because you use a lot of data that is uncleaned, but you also have to think about this stuff here. So you're going to need to pick your correct LLM. One specific LLM, one type of model will work differently for specific data. So if you're like in, finance, it's going to be working differently if you pick one LLM that is suited for security logs. So that's not good. You need to pick an LLM that is very well adjusted to the task at hand. Then you want to use better prompts. And this is like when you think about, OK, am I going to become a prompt engineer? Yeah, probably you should. Because once you start asking, hey, AI assistant, what happened to my log? And you're going to get 0 results or shitty results, then probably you are at fault. So you have to think about all those queries that you're going to ask. You're going to have to like think about better prompts and just take your time. Then you're going to select the right database. That's also very important. It's just like an LLM. It needs to be very specific to your use case, and depending how much you want to pay for it, etc., and how fast you want to work. And then let's say everything, you're going to be happier because you're going to see like, yeah, this is working better. I think it's getting there. And then there are those guys that chose the other path that, OK, yeah, whatever. I'm going to use less data. It's just I have a couple of GitHub repos, and I cleaned it. Yeah, sure, I just had 2 knowledge bases, 2 articles. And then you're going to see better quality results. Yes, true. And then you're going to be happy, and you're going to go to production. And you're going to cry again because, yeah, whatever happens in testing doesn't happen in production. In production, you're going to get like, tons of data, different scenarios. Users will ask different type of questions, different prompts. So you're going to get those results that are going to make you cringe. So that's not a problem. You can take all that information, and with the help of observability, you can actually take a look at your full LLM response, at your prompt response, and just analyze it and ship it back into testing. So pretty much that was the advice of smarter guys than me in observability that said, yeah, don't cry about it. Whatever happens in production, do it back, ship it back into testing, and retrain that model. So you can either use fine-tuning or whatever method you want. But yeah, this is a lengthy process. I mean, nobody woke up and just said, yeah, tomorrow I'm going to become an ML engineer. No, so people actually spent time, played with it, and learned about it. So it's a work in progress. Right, so reaching the end almost of my talk, it's important to understand that some of the takeaways is that once you want to start using generative AI, even if you're not a machine learning engineer or data scientist or whatever, you need to take some things into consideration. So assess your data, incoming and outgoing. Cleaning it is very important. You've seen that if you don't clean your data, pretty much you're going to get really bad results. And they know what they say. You can use the method that you want, like fine-tuning or retrieval augmented generation. There are many others available. The research is phenomenal. So by the time I'm looking right now, Google 10 other methods probably appeared. So yeah, the research is actually pretty strong. It's going pretty well. Choose your correct large language model or small language model. Some research is saying that actually small language models perform better than LLMs, depending on the use case, depending on the scenario. And then you're going to choose the vector database accordingly, serverless, non-serverless, whatever, and tweak your prompts. So I can give some of my examples. First time when I play around with an AI assistant, I just used my Google search experience. So I was typing something, hey, what about that log that happened in that date? And I was like, okay, some random facts. Yeah, then I tried to think about it. No, maybe I should put it into more context. What do I want to achieve? Okay, if I'm on call right now, do I want to know what happened to it? Was it service disrupted? Was it, I don't know, something going on with database, with a specific knowledge base that is related? So grab all that information. Don't just blur out your first instinct. Just put all the information and think like, okay, if I would be a machine, how would I do it? So do that. And then you're going to get amazing results. So step by step is going to improve, and you're going to get better results. And then get user feedback. So speak with your colleagues or speak with ML teams, and they'll be happy to how can I say, improve that experience. Even if it's about UI, even if it's about how you type and where you type that information in the UI when you're communicating with the AI assistant, even if it's about, okay, how can I improve the query? Maybe should I do a custom script? Maybe, anything that will help. Should I automate something like this? Do I want to see a different workflow with the AI assistant? Just give your feedback. It works, wonders in that sense. Yeah, and what else? You can, you can check out these resources. I put it especially for this talk. It's like there is super little what I put on this slide because the research is quite amazing, and you have to say stop in a presentation of 30 minutes. And anyway, you can download the slides of this talk and all my previous talks from my GitHub repo. So I'm going to give you a minute just to go there, download it, and you can ping me on LinkedIn. I'm here today and tomorrow. And yeah, let's thank Ricard and everybody from DevOps Barcelona for making it special, and thank you very much for your time.
Yeah, we have some questions, but since this is a very new topic, let's see. So first, they ask about if you could name your top 3 vector database choices, if you have.
Yeah.
It's very new, so.
Cool. Yeah, I've worked with a couple, but I'm going to mention the first one that comes to mind because it's Elasticsearch, my ex-employer. Yeah, the idea is that it's good. Why? Because Elasticsearch is a company that works with search, right? So it's elastic, it works with search. They're doing a lot of, how can I say, they're investing quite a lot in the whole generative AI workflow. So it's good. But I've seen other vector databases that also are pretty good. It's just like, I've been to Malaga to another conference, and they were actually at the DevBCN this year, and they were doing a lot of demos. On top of my mind right now, because I'm super nervous, I don't remember exactly how it was. But yeah, I mean, just give it a go. If you type RAG, because they use, all of them pretty much use RAG, obviously. So if you type RAG and vector databases, you're gonna get quite a lot of information. Also, the vector databases that I mentioned there on that use cases slides are quite useful. Quadrant is another vector database that the research says, well, not only the research, they say it's super popular and faster, even than Elasticsearch. Whatever, you have to try it. So Vespa, I think, is another company. So yeah, the list is long.
Yeah, and it's quite new, so.
Exactly.
We'll so they're asking if you know or you can recommend some good MLOps, AIOps, or in this, let's say, ecosystem frameworks that are emerging, or?
Frameworks in what sense? Like tools or
tools, yeah, I guess.
Or anyway, I could give some. I mean, you can contact me later and we can have a chat. The idea is that there are lots of them, and I would recommend just looking at the free resources one or the ones that have like the GitHub repos, you know, in the frame of open source. Sorry. Because they are the ones that you can just fork it and you can have a go at it, and you'll have like examples. There are lots of that offer actually exercises how to play with the entire workflows. There's actually a GitHub repo that they also created. They published a book recently called the LLM Handbook. I'm not advertising, I'm just saying that the GitHub repo is there. You can actually go and play with how to become an MLOps engineer, in the sense that it makes you start from the beginning with the LLM workflow. So that's actually pretty cool. All the information is there for free on GitHub, and you could also get the book, but it's pretty much the same like the GitHub repo. And frameworks, there are tons of frameworks. The idea is that it's a lot of information. I myself was trying to study and was trying just to study the part with AWS, and it's a lot of information. So it depends. You need to choose carefully. Like, okay, should I do AWS? Should I do what's there free on the GitHub repos? I would just say, yeah, do the stuff that is free and it's open source.
So they were asking about when it comes to a model, and then you need to fine-tuning, of course.
Yeah.
They're asking, which is a very open question, how much it costs, and it can be super expensive, right? Depending on how big it is and all that.
Yeah, it's true. It's super expensive. Well, for example, just to give an example, I'm not sure about other companies, but if you're going to use AWS and just to train yourself for like a basic certification in ML or AI, they actually advertise you not using your test environment. Because it's going to cost a lot of money. So just like find free resources that people have actually used before. I'm not saying that you shouldn't use it, but if you forget an instance there that is like Bedrock or SageMaker that is running some notebook, and I'm just going to go and have some fun and come back after 2 days, then you're probably going to be bankrupt. So yeah, it's pretty expensive.
Yeah. So they're asking if that's again an open question because of this. If you think that in the future combining generative AI with other tools could allow us to, like, even without knowing the system, predict anomalies and even act on them, or it's still a bit gray? Well, it's a very open question, no?
Yeah, well, I'm not sure about not knowing the system, not knowing the platform, or what.
Well, they say not understanding the internal mechanics of the system.
Okay.
But
yeah, I'm pretty sure. I mean, we go back to the whole workflow or the whole philosophy of non-vendors. Right, so I think OpenTelemetry and all the open source observability projects that they want to get information from all like platforms without being super knowledgeable about them. I think that's all about, right? Because it's actually pairing it and integrating it with that specific vendor. So as long as the vendor does some minimal work of integrating it, or pretty sure, I mean, all the vendors use programming languages. At some point, you'll know how to pair it, and you need to do some programming work there, how to pair it with open source. But I'm pretty sure it's going to be done, and people are doing it at the moment, so yeah.
And the final one, which is something I thought about. So do you think MLOps will become an integral part of DevOps, or will specialize like a completely different field, or a bit of everything maybe?
Yeah,
We'll see, no?
I think it's like in the meme I put there. So it's like, whoever invented DevOps, I mean, we are the MLOps guys right now. I think, yeah, we are looking at ourselves right now as being rebranded as MLOps engineers. And because this is how it is, it's a new workflow that is being gonna ingest all that information, and it's gonna happen. So I'm not saying that, hey, you should all learn how to use generative AI. It's just it's gonna be part of the same workflows that we came to get to know in the last 5 years. So everything will be eaten up by the new trend. So yeah, we are already MLOps engineers in one way or another.
All right, thank you very much, and I hope the situation in Valencia gets resolved soon, because, yeah.
Okay, thank you.